Hello guys, so we have this topic under sequences and series. Okay, so the question is asking us to say write the series using summation notation. Okay, so for the summation notation, the first thing which you're supposed to do, you're supposed to identify the general term. Okay, and the limit of the summation. Okay, so there are two things which you're supposed to know, and when you are writing the summation notation. Okay, so the first thing, you're supposed to identify the general term, okay, and the second thing, you're supposed to identify the limit of the summation. Okay, the limit of the summation of the notation, limits. Okay, so these are the two things which you're supposed to know. Okay, so now let us dive into this question. The first question, we have 1 plus 5 plus 9 plus 13 plus 17. Okay, so they want us to write the series using the summation notation. Like I said, there are two things which you're supposed to know. The first thing, you're supposed to identify the general term, and the second thing, you're supposed to identify the summation of, or I can say the limit of the summation notation. Okay, so the general term, as you can see, this, what type of the series is this? What type of the series is this? So this is an arithmetic series. Okay, this is an arithmetic series. Okay, so it is an arithmetic series. Okay, and we know that for the arithmetic series, the general term, which is the GT, we know that we use an is equal to our first term plus n minus 1 d. Okay, so where a is the first term, n is the number of terms, and d, which is the common difference. Okay, so as you can see here, we have our first term, which is equal to what? Our first term which is equal to 1. Okay, and the common difference, you just look at the difference between the two terms. Okay, so as you can see, we have the first term, which is a1. In other books they use t. It can be t or a. Okay, so a1, a2, and a3, a4, a5. Okay, so to find the common difference, you're supposed to say a2 minus a1. You're supposed to subtract a1 from a2. Okay, so what is our a2? Our a2, which is 5, minus a1, which is 1. When you subtract, you're getting 4. Okay, so that's your common difference. So our common difference is equal to what? To 4. Okay, so now we can find the general term using this formula. Okay, so now let us try to. Okay, so we have our general term formula, which is an is equal to a plus n minus 1 d. Okay, so our a1, which is equal to 1, and our d, which is equal to what? Our d, which is equal to 4. Okay, so now the next thing which you're supposed to do, you just plug in the values. Okay, so the values of a, since we're finding the general term, okay, for the general term, where there's n, you don't put anything. Okay, it's more like we're finding the nth term. Okay, so our a1, which is 1, plus n minus 1 times 4. Okay, so now after doing that, now you start expanding. Okay, so what is 4 times n? 4 times n, 4 times n, which is 4n. 4 times 1, negative 1, which is negative 4. Okay, so now the next thing you're supposed to do, since we have negative 4 and 1 there, okay, so negative 4 and 1, when you do your calculation, you're going to find 4n. When you say 1 minus 4, what is 1 minus 4? 1 minus 4, which is negative 3. Okay, so this is our what? Our general term. Okay, so now the next thing which we're supposed to do, we're supposed to find the summation. Okay, so for the summation, since we have 5 terms, as you can see, we have A1, A2, A3, A4, and A5. Okay, so meaning that we have 5 terms, so our summation would be equal to 5 terms. Okay, so now let us write the notation. So the summation notation will be equal to 5. Okay, so now using this sigma notation, which is the sigma, how many terms do we have? We have 5. Okay, and our first term is equal to 1. Okay, our first term is equal to 1, so n will be equal to 1. Then you just write the general term, which is 4n minus 3. Okay, so that's your answer. That's how you answer such questions. Okay, so now let us proceed to the second one. Okay, question 2. We have 1 minus 2 positive 3 minus 4 positive 5. Okay, so what type of series is this? What type of a series is this? Okay, so this is an infinite alternating series. Okay, so it is an infinite alternating series because the absolute value of the terms increases by 1. Okay, it is increasing by 1. Okay, so like I said, in order for you to write the summation notation, the first thing you're supposed to identify the general term. You're supposed to come up with the general term. Okay, so the terms follow the sequence n, but the sign alternates, and infinite alternating series. Okay, so since the first term is positive, so we are going to alternate that positive number. Okay, so to alternate simply basically means like alternating, the symbols, like since the first term it is positive, meaning that we're going to use a negative one. Okay, so our general term will be I'll use GT, so it will be GT. Okay, so GT, which is a general term, will be equal to, so we're going to alternate the first term, so it will be negative since it is positive. Then on the power part there, we're going to put n plus 1. Okay, n plus 1 times n. Okay, so in short, you're supposed to come up with something which is going to work. Okay, you're supposed to come up with a general term where when you plug in the values of n, you're supposed to give you this. Okay, so these, I can say, dashes, they are ellipses. Okay, so the ellipses, they basically indicate that the numbers are still going to infinity. That's the reason it is called an infinite alternating series. Okay, the numbers are still going. Okay, so then now the summation notation will be summation, since the numbers, they're going to infinity, it will be infinity. Then what is our first term? Our first term, n is equal to 1, and our general term, which is negative 1, n plus 1 times n. Okay, if you want, you can put n in front. Yeah, it's up to you. Okay, you're still going to get the same answer. Okay, so, or you can write it as like this. Okay, where we have n is equal to 1, n negative 1, n plus 1. Okay, so if you want to prove this type of series, if you want to see if what you're going to get is the same as the given alternating series, you just pick the values of. Okay, so if I say n is equal to 1, n is equal to 1, n is equal to 2, n is equal to 3. Okay, so I just want to prove these. Okay, so we are using this one. This is our summation notation. So if n is equal to 1, what will be our first term? N is equal to 1. Okay, so our first term, we're going to say you're going to say n, you get this one, n minus 1, n raised to the power n plus 1. So when n is equal to 1, what would be the value of our first term? Okay, so you plug in 1 where there is n, 1 plus 1. So 1 plus 1, which is what? 1 plus 1, which is 2. So it will be negative 1 squared. When you do the calculations, you're going to find 1. Okay, so we are still getting this one. Okay, so now let us try if n is equal to 2, if we're going to get negative. Okay, so for n is equal to 2, you use the same n times negative 1, n plus 1. So you just plug in, if n is equal to 2, where this n you plug in 2. Okay, so you're going to have 2, negative 1, and there 2 plus 1, negative 1. When you add, you're going to have 3. Okay, so what is a negative 1 cube? Negative 1 cube, which is negative 1. Okay, so if you multiply, you're going to get negative 2. Okay, so this formula matches our notation. Okay, so this summation matches our notation, or I can say matches the series using the summation notation. Okay, so now let us proceed to the third one. Okay, so we have the third question. We have 1 plus 0.1 plus 0.01 plus 0.001. Okay, so what type of series is this? So this is a geometric series with the first term a1 equal to 1 and now common ratio which is equal to 0.1. Okay, so since we know that our first term, which is a1, is equal to 1, this is our a1, a2, a3, a4. Okay, and our common ratio, we know the formula, which is a2 over a1, or t2 over t1, the same. Okay, so our a2, which is 0.1 divided by 1, which is equal to 0.1. Okay, so since we have found our first term and the common ratio, the first thing you're supposed to state the summation notation. Okay, so the summation notation for this one, you're going to say summation. How many terms do we have? We have 4. Okay, so 4 terms. Our first term, which is equal to 1, which is equal to, okay, so our first term, okay, so you're going to write a, our common ratio, which is 0.1, n minus 1. Okay, so this is our summation notation. Okay, so now let me explain more about geometric. So for geometric, we follow this formula. Okay, so where n is equal to k, then here I'll just put z on top. Okay, so here we're going to have a r, which is the first term multiplying with or multiplying by the common ratio n minus 1. Okay, so that's a formula if you have geometric series. Okay, so you follow this one, geometric series, you follow that one. Now let me try to prove if you're going to get the same series. Okay, so since we know that we have a, which is this one, a 0.1 n minus 1. Okay, so our first term, which is 1, 0.1, 1 minus 1, you're going to get 1 after doing your calculation. Okay, so if n is equal to 2, you do the same thing, substitute our first term, which is 1, 0.1, 2 minus 1, where there is n, you just plug in 2, you're going to find 0.1. Okay, then you can conclude by saying that this is our summation notation for this sequence, or I can say series, for this series, which is Z, a geometric series. Thank you for watching.